Okay, here's a related rate problem that I just really dig. It's got, it's got this person walking away from a lamp pole. This lamp post is 10 feet tall. He's 6 feet tall, and he's casting a shadow right here. This Y, this part right here. This is his shadow. So Y is the length of his shadow. And X is the distance from pole, his distance from pole, from light post. Okay, so those are the two things that we have here. Now, we know this, that we're given that he is moving away from that post at 3 feet per second. So a 6 foot tall person walks away from a 10-foot lamp post at a constant rate. So we know this. This is what we're given. dx dt is equal to 3 feet per second. Okay? So we're given that. Now, what I want to do is I want to find a couple of things. I want to find this. I want to find dy dt. In other words, I want to find how fast is the length of his shadow changing. And I want to find how fast the tip of his shadow, this point right here, is moving away from the light post. From post. That's what I want to find. I want to find those two things. Now, if you think about it, this second part right here, the tip of his shadow, the distance of his shadow, the tip of his shadow from the light post is x plus y. Right? It's the distance he is away and then the distance from him to the tip there. So what we want to find here is we want to find the rate of change of x plus y. That right there. That's what we want to find. Now, so our challenge is we need to find a relationship between, what we're given, dx dt, and what we want to find. Well, we got these similar triangles, right? So look at this. We've got this similar triangle, this big triangle, and we could say 10 is to x plus y, what 6 is to y. See? Because we've got this triangle right here, and then we've got this big one. So this big triangle and this little wee triangle here, those are similar. Okay, now I want to do this. I've got this expression here, and what I'm going to do is I'm going to multiply. You could think of it as cross multiplying. But what I'm going to do is I'm going to multiply both sides by y times 10xy. So y times, no, not y times 10xy, but y times xy. X plus y, that is. I'm sorry. So, see, I multiplied the left-hand side by y times x plus y. In other words, I'm multiplying it by the denominator. And this over here is 6, and I'm going to multiply that by y times x plus y. Now this is just, all this is cross multiplying, really. I mean, you could think of it that way. That's a simple way to look at it. Now what happens is this cancels, this x plus y on the left side, and this cancels on the right. So now what we have is, we have 10y on the left is equal to 6x plus 6y on the right. Now I could simplify that a little more by bringing the 6y over here, and I get 4y equals 6x. Now let's see, at this point we're actually ready to differentiate. I could say, well, let me go ahead, this is 4y prime equals 6x prime, like that. And now, remember what I'm trying to do. I'm trying to find this, dy dt. That's what I'm trying to do. And I've been given dx dt. So I can put in a 3 in for x prime. So here's what I have now. I have 4y prime equals 6 times 3. Yeah, there it goes. So now I've got this. I've got y prime is equal to 18. I'm sorry, 18. Whoops. 18 over 4. So that was the first part. Now, I can actually simplify that a little bit because y prime, 2 will go into 18 9 times and 2 will go into 4 2 times. So there is the rate at which the length of his shadow is changing. And I could say, well, this is 9 halves. Whoops. 9 halves feet per second. Yeah. So dy dt, the rate at which the length of his shadow is changing is 9 halves feet per second. Now we're ready to calculate, well, how fast is the tip of his shadow moving away? So let's see what we've got now. We've got d dt of x plus y. Well, that's going to be x prime plus y prime. Now we know x prime is going to be, so we have, we know that x prime is 3, y prime is 9 halves, and all this is feet per second. So this is going to be 6 plus 9 over 2. Right, just getting a common denominator there. And that's going to be 15 over 2. So the rate at which the tip of his shadow is moving away is 15 halves feet per second.